Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. Were you looking out your window looking for this video? This is the great group, the Bengals, singing "Be With You." Mathematics shall always be with you, won't it? I hope so. Of course it will, whether you like it or not. So let's talk about complex numbers as two-dimensional vectors. Some nice pictorials here. Take a pause and look at them if you want. We're moving forward. And what we want to do here is we want to take complex numbers, represent them with vectors, so we can do all things that we have done with vectors with the complex numbers. It shall help us out. First thing we're going to talk about is the Argand plane, the complex plane, or the Argand plane, and Argand diagrams. The Argand diagram is, or the Argand plane is represented by a horizontal real number axis and a vertical imaginary number axis. And we've talked about complex numbers in the form of z equals a, the real part, plus bi, the imaginary part. So again, real axis, imaginary axis. Okay. Okay. So, Argand diagram. So just like we did with vectors before, like if I had the vector 3, 4, to graph that vector, or to represent it on the plane, I would go over 4, right? And up 3, yes, just like that. And then start to finish would be the vector 3, 4, yes? Oops, I did that wrong. So let's just pretend that this was 3 and this was 4 and it's not the scale. Build a bridge and get over it. Okay, so same is true with complex numbers. The complex number 2 plus 3 over 2 on the real axis, up 3 on the imaginary axis. There's our vector, -3, -1. To the left and down, and there is our vector OS for the complex number -3 minus I. Very simple, very easy. You should have zero trouble with this. Okay, so for A, Z1 plus Z2, clearly that's going to be 3 plus 1 is 4. I minus 4i is -3i. Let's take a look and add those geometrically. I'll do my best with the arrows here. So let's do 3 plus I. So the vector 3 plus I is going to start here, go over 3 on the real axis. Oops, messed me up. Come on, come on, come on, come on, come on. Okay, so 3 plus I starts here at the origin, over 3 and up 1 on the imaginary axis, and there we go. I didn't quite hit the point. So now I'm going to go to the right 1 and down 4 for z sub 2. 1, oops, come on, undo that. It's not being my friend. Over 1, down 1, 2, 3, 4. Okay, and so the resultant vector right here, bam, should be 4 minus 3i, is it? 1, 2, 3, 4 on the real axis, and then down 3, 1, 2, 3 for minus 3i, and there we go. Okay, so hopefully that's not a big deal. Let's see if we can do z1 minus z2. B, z1, so 3 minus 1 is 2, and then I minus a -4i is a positive 5i. So we should end up with the vector 2 plus 5i when we subtract these. So again, we will start with 3 plus I, which we already know is this vector here. See if I can get the point. A little bit better. And then we're going to subtract 1 minus 4i. So it just goes in the opposite direction. So instead of going to the right one, I'm going to go to the left one. Instead of going down 4i, my pen is not being my friend. Instead of going down 4i, I'm going to go up 4i. So 1, 2, hold on, I got to start there. So 1, 2, 3, 4. So let's back it up. Not bad. And so my resultant vector, if I draw it from start to finish, tip to tail, that should be 2 plus 5i. 1, 2, 1, 2, 3, 4, 5. Hip hip hooray. Okay, so same thing as how we were working with vectors. It's just that the axes and the plane has changed. Okay. Same thing here. I don't think I'm gonna bore you with it. I think you got it. I'll just do one. Let's do b, z minus 2w, since it's subtraction. So that would be 1 plus 2i minus 2w is going to be 6 minus 2i. So 1 minus 6 is negative 5, and 2 minus a negative 2 is plus 4i. So that is the subtraction, and let's see if we get that on the complex plane, or the Argand plane. Okay, so we start off with z, which is 1 plus 2y. So to the right 1, up 2, bam. Okay, then we're going to start here, and we're going to subtract. Let's just think about this. Let's write it out. So it's 6 minus, 2 times 3 minus I is 6 minus 2i. So we are going to subtract that. So instead of going to the right 6, I'm going to go left and then up. So let's see how that works out. Okay, so I'm going to go to the left 6. 1, 2, 3, 4, 5, 6, and then up 2. So let's see if I can get that arrow right. Not too bad. And then let's do the resultant vector. Tip to tail, tail to tip, tip to tail. And there we go. So that should be negative 5 plus 4i. Let's check it out. 1, 2, 3, 4, 5. 1, 2, 3, 4. Wait a second. What did I do? 1, 2, 3, 4, 5. 1, 2, 3, 4. So I must have done something wrong. Let's check it out. Over 1, up 2. Yes. And then minus 6. Up 2. Did I go too far? 1, 2, 3, 4, 5, 6. 1, 2. 2 times 3 is 6. What is the matter here? So that is 1, 2, 3, 4. Why am I doing this wrong? Oh, because I went 3i instead of 2i. 1 plus 2i, 3i. So, okay. So, sorry for that mess up. It's just this vector was up 1. It should be down 1. Hopefully you caught that. And you're sitting there. Come on, Becker. So, yeah. This should be this vector. And then that would go to here, sort of. And then we would be good. Okay. All right. You get the picture. Sorry for the mess up. And the final thing I'll show you is that we already know that if we have z equals x plus iy, we represent its conjugate using z star, and that's x minus iy. And how does that look on the Argand plane? Well, first of all, if I have vector OP, then and that represents z, then its conjugate we're going to represent with a prime, and then it's just x negative y. So all that is going to change is the vertical orientation, or the vertical direction. So 2 plus 4i is going to be here, and its conjugate 2 minus 4i is here. It's just going to be a reflection in the real axis. Same thing with, let's see, what do we have here? Negative 3 plus 2i and negative 3 minus 2i are conjugates of each other, as are positive 3i and negative 3i. All right, that is it. Hope you enjoyed it. Let's check in with the Bengals, see how they're doing. And I am... Oh!